In this video, we're going to talk about how to solve a systems of equation using the elimination method. By the end, you should be able to solve a systems of equation using elimination. The word eliminate means to get rid of, right? We hear things like eliminate weeds, or eliminate mold, or eliminate insomnia or chaos, or eliminate the competition. The goal is to get rid of it, is to make it disappear. Our strategies for solving systems of equations, we've got 3 of them. We've already looked at graphing, we've looked at substitution, and now we're going to take a look at our third and final method, which is elimination. What the elimination method does is it seeks to eliminate either the x or the y. So in order to figure out which one to eliminate, you want to look for the one that has the same coefficient. Now you're combining the equations, so you're adding or subtracting based off of the signs in front of the numbers. You may or may not have to distribute a subtraction sign or a -1 across the entire equation so that you have an opposite. Remember, the only way that you're going to be able to eliminate variables is if you have 0 pairs or opposites. Our steps for eliminations are to line up the equations vertically. You want to make sure that both equations are in standard form or are in standard light form. They're not going to be perfectly in standard form, but we need them and we need the x and the y on the same side. You're going to choose the variable to eliminate, so you're either going to choose x or y. Again, you're going to choose the variable that's easiest to eliminate, the variable that's easiest to get rid of. Combine your 2 equations and then solve it for the remaining variable. The variable that you solved for, you're going to plug in that answer into one of the 2 original equations so that you can find the second variable for your ordered pair. Okay, so let's look at the following example. We have 3x minus 5y equals -16, and 2x plus 5y equals 31. Using the elimination method, we want to make sure that our equations are lined up, and they are. We want to make sure that x's are above x's, y's are above y's, and constants are above constants. And so now that that part's done, now we want to eliminate one of the variables. So we're looking for the one that's easiest to eliminate, and that's going to be the one that has the same coefficients. So if we look at the y's, both of the y's have a coefficient of 5. And we're going to be able to eliminate these because one of them is -5 and one of them is +5. So that's the variable that we want to eliminate. I'm going to combine the equations. So since 3x and 2x are both positive, I'm going to add them. This is going to give me 5x. -5y plus 5y, those cancel, so that's gone. We've eliminated that variable. And then -16 plus 31, because those are opposites, we're going to subtract, take the sign of the larger number, and so that would end up being 15. So we have 5x equals 15. That means x is going to be equal to 3. Now that I know what x is, I take that and I plug it back into one of the 2 original equations. Doesn't matter which one. I might pick the first one just because there's no negatives in this one. So 2 times 3 plus 5y equals 31. That's 10 plus 5y equals 31. If I subtract, well, not 10. 2 times 3 is 6. Let me change those light. So 6 plus 5y equals 31. Subtract 6 from both sides. 5y equals 25. Divide by 5, divide by 5, y is equal to 5. So now my ordered pair here is 3, 5. Now I want to check it in both of my original equations. So I go to check. Again, 2 times 5 plus 5 times, or 2 times 3. Plus 5 times 5 equals 31. So that's 6 plus 25 equals 31. 31 equals 31, so that checks out. I take the other one, so the 3x minus 5y equals -16. Again, 3 times 3 minus 5 times 5. So 9 minus 25 equals negative 16. That negative 16 equals negative 16, so that also checks out. So I know that my solution here is 3, 5. Looking here, we have 5x plus 2y equals 6, 9x plus 2y equals 22. Again, these are already lined up. I need to figure out which variable to eliminate. Because the y's have the same coefficient of 2, that's what I want to eliminate. In order to eliminate them, one of those has to be a negative 2y. So I'm going to pick one of the equations and I'm going to multiply that equation by negative 1. So I'm going to take the top one. I could choose the bottom if I wanted to. I'm choosing the top. Negative 5x minus 2y equals negative 6. Remember to multiply everything by negative 1. The bottom equation did not change, so the bottom equation is 9x plus 2y equals 22. I can now I can now eliminate. So we're going to combine. Negative 5x plus 9y gives me 4x. Negative 2y plus 2y, that cancels, that zeroes out. Negative 6 plus 22 gives me positive 16. So 4x equals 16, that lets me know that x is equal to 4. Now that I know that x is equal to 4, I can take that and plug it into one of the two original equations, so I'm just going to put it back into the top one. So 5 times 4 plus 2y equals 6. That's 20 plus 2y equals 6. That's 2y equals negative 14. As y is equal to negative 7. So my point here is 4, negative 7. Now I want to check it in both of my original equations, so I'm going to go back. Even though I've already used the top equation, I'm going to check it anyways. So 5 times 4, there's my x, plus 2 times negative 7, that's my y, equals 6. 20 minus 14 equals 6, and 20 minus 14 is 6, so we're good there. 9 times 4 plus 2 times negative 7 equals 22. This is 28 minus 14. That's not 28, that's 36. 9 times 4 is 36. That's 14 equals 22. And 36 minus 14 is 22, so that also checks out. So I know that my solution of 4, negative 7 is correct. Looking at this next one, we have 2m minus 5n equals negative 6, 2m minus 7n equals negative 14. They're already lined up. The variables that I'm going to want to cancel out this time are the m's. Again, one of them has to be negative, so I'm going to multiply one of the equations by negative 1. I picked the top one, so this would be negative 2m minus 5n, or plus 5n equals positive 6, because everything gets multiplied by negative 1, so everything becomes the opposite. And the bottom one, I didn't change anything there, so I'm just going to copy that over. And then I combine. The m's cancel out. Positive 5 minus 7n, that's negative 2n. 6 minus 14 is negative 8. So n would have to be positive 4. So knowing that n is positive 4, I take that, I put that into one of the two original equations. Again, I'm picking the top one just because it's got a little bit smaller numbers. 2m minus 20 equals negative 6. 2m equals 14. M is equal to 7. And so my ordered pair here would be 7 and 4. M being 7, N being 4. I want to check it in both equations. So 2 times 7 minus 5 times 4 equals negative 6. 14 minus 20 does equal negative 6, so we're good there. 2 times 7 minus 7 times 4 equals negative 14. 14 minus 28 equals negative 14. So we're good there. So I know that my solution of 7, 4 is correct. Here we have 8a minus b equals 3. We have b equals 8a minus 5. Again, in order to solve this systems, I need to get the a and b on the same side. I need to have it in standard like form. So that would cancel out. My new equation here would be negative 8a plus b equals negative 5. We want to line them up. So we want to line them up. So I would have negative 8a. So 8a minus b equals 3. That didn't change. Negative 8a plus b minus 5. I'm going to eliminate here. What you'll notice is that both of these, the coefficients in front of a are already opposite. That cancels. The coefficients in front of b are also opposite. So that cancels. So we're left with 0 on this side. 3 minus 5 is negative 2. That's not a true statement. And so this would mean that there is no solution for this problem. But before we could establish that, we needed to make sure that both of these were in standard form. We also want to be able to write the equations. So a youth group leader visited Mammoth Cave. 2 adults and 5 students in one van. So 2 adults, X, plus 2 students, or plus 5 students, Y, paid $77. 2 adults, X, and 7 students, Y, paid $95. So I've got 2 equations in standard form. This is going to be a little bit easier for me to solve using elimination. Before we've been using substitution, but I can solve this using elimination. I'm going to need one of these equations to be the opposite. I'm going to solve for the x. I'm going to eliminate the x's here because they have the same coefficient. So I have negative 2x minus 5y equals negative 77. Bottom equation I didn't change, so I'm just going to copy that down. And then we'll eliminate. So we'll combine. The x's go away. Negative 5y plus 7y, that's positive 2y. Negative 77 plus 95, that's going to be positive 7 or positive 12. It's positive 18, which means y is equal to 9. So the cost for a student ticket was $9. To figure out the cost of an adult, pick one of the 2 equations. Plug in the y, so that's 5 times 9 equals 77. 5 times 9 is 45 equals 77. 2x equals, if I subtract 45 from both sides, that is 32. And so x is equal to 16. So the cost of an adult is 16. The cost of a child is $9. So $16 for adults and $9 for children. Before watching the next video, please consider the following. To identify the variable to eliminate, what do you look for?